Let's do an example calculation of the type that you'll need to do for this week's lab. In this story, a student wishes to determine the percent composition of a penny minted in 2006. She knows two things about this penny. One is that a penny is a heterogeneous mixture of two elements, zinc and copper, and she also knows the difference in chemical properties of zinc and copper, specifically that zinc will react with hydrochloric acid, whereas copper will not react. So in her experiment, she took a penny, cut it roughly in half, found the mass of that piece of penny of about 1.148 grams, took that piece of penny, dropped it into some hydrochloric acid, wait until the acid had consumed all of the available zinc, fished the penny piece out of the acid, rinsed it down as water, dried a paper towel, and finally found that what remained of the penny piece was about 0.032 grams. So from this information, we want to determine the percent composition of the penny with respect to copper, as well as percent composition with respect to zinc. So first off, what is percent composition? Percent composition is a way of quantifying the composition of a mixture. And it's always with respect to a particular component of that mixture. So percent composition with respect to copper is simply the mass of the copper present, mass of that component present in the mixture, compared to the mass of the mixture, in this case, our penny, times 100%. So to find percent composition with respect to copper, we need to find simply two numbers, the mass of copper in the penny, and compare that to the total mass of the penny. So going back to our word problem, 1.148 grams, that was the mass of the piece of the penny. And because a penny is composed of just simply zinc and copper, this number 1.148 is equal to the mass of the copper that's present in the penny plus the mass of the zinc that's present in the penny, the mass of the two components of the penny. After dipping the penny in acid, the acid consumed, removed all the available zinc, and then what was left only had a mass of 0.032 grams. So our other number then must then be simply the mass of just the copper, because according to the story, the hydrochloric acid is not going to affect the mass or the amount of copper we have in their penny. So percent composition with respect to copper is the mass of the copper, which from the story is 0.032 grams, compared to the mass of the penny, which is the mass of the copper plus zinc of 1.148 grams times 100%, which gives us a value of 0.032 grams divided by 1.148 times 100, about 2.7875% copper. We're only allowed to have 2-cent figures in this answer, so rounding to 2-cent figures, we'll have 2.8% copper. So she can conclude that from her data, her penny is approximately 2.8% copper by mass. Now let's do the same thing, but now with respect to zinc. So percent composition with respect to zinc is going to be the mass of zinc present in the penny compared to the mass of the penny itself times 100%. So our percent zinc, mass of zinc, well, what is the mass of zinc? Going back to our original numbers, 1.148 grams, that's the mass of copper plus zinc. If 0.032 grams is just the mass of copper, then what's not copper must be zinc. So subtracting 0.032 grams from 1.148, 1.148 minus 0.032 grams gives us a difference of 1.116 grams. And that is then the mass of zinc in the penny. So 1.116 is the mass of zinc compared to that same total mass of the mixture, 1.148 times 100% gives us a value of 1.116 divided by 1.148 times 100 of 97.21% to the 4-cent figures that we're allowed to have in this calculation. So she can now conclude that her penny is not only 2.8% copper, by mass, but also 97.21% zinc by mass. Another way we could have calculated the percent composition with respect to zinc, or alternatively, a way we can check the reasonableness of our answers, is to realize that because this is a two-component mixture, just contains zinc and copper, what's not copper must be zinc. So therefore, the percent copper plus the percent zinc, the sum of the percent compositions of all my components, must equal 100%. So if I know one, I can calculate the other. So in this case, if I've already calculated the percent copper, I can then calculate percent zinc. So percent zinc is then going to be 100% minus the percent copper. You then have percent zinc equals 100% minus the 2.7875 number, less rounded number. And when we do that calculation, we get 100% minus 2.7875, a difference of 97.21%, which is exactly what we got in the other calculation.